Hi dear students, welcome to Gravity Coaching Center, Tirupati. Today let us discuss myopia, eye defect and problems. See here, what is myopia, eye defect? See, myopia, eye defect is also called as nearsightedness. Means a person who is suffering with myopic eye defect, he can see the objects which are nearby to him. Means nearby objects can be seen clearly by that person, whereas he cannot see the objects which are very far from him, or far objects cannot be seen by this myopic eye defect person. Okay, now we will see why this myopic eye defect will come. What are the reasons for that? So, the main reason is due to the elongation of the eyeball and excessive curvature of the cornea and eye lens, due to which the focal length of the eye lens decreases. See, elongation of the eyeball. See here, normal eye, it will be of this size, and elongated, see, it will be elongated in this way. So what happens is, see this rays, when the object is at very far distance, suppose it is at infinity, parallel rays will be coming, right? And at the cornea and the eye lens, they what? Bend, and the image is perfectly formed at the retina for the normal eye. But for the myopic eye, when the object is at infinity, these parallel rays, they will not be able to converge at the retina, due to which, see, the image is blurred. What is actually happening is, due to excessive curvature, more curvature is there. This eye lens and cornea are having more what? Curvature, due to which more bending is taking place. More the curvature, more bending of rays will take place, and instead of the image to be on retina, it is falling before the retina. You see, the rays are converged before the retina. If the rays are converged on the retina, you will get sharp image. But since they are converged before the retina, the image will be blurred on the retina. Okay. So to correct what is actually happening here, more bending is taking place due to excessive curvature of cornea and eye lens. So to correct, what we have to take care is, we have to reduce the bending. So to reduce the bending, we are using what? Concave lens. Why? Because concave lens are also called as diverging lens. So these concave lens will actually diverge the rays a bit, and after passing through the concave lens, the rays will bend after passing through the cornea and eye lens, so that the image will be sharp and clear, will be formed on the retina. This is regarding this eye defect, myopia. So in the exam, the questions can be of this way. So they will ask you, make a ray diagram to show how the eye defect myopia is corrected using suitable lens, or with the help of ray diagrams, show the formation of image by myopic eye, correction of myopic eye by using an appropriate lens. So both of them are of the same kind of questions. So just they will twist, that's all. Okay, let us move to the next question. What are the values of near point and far point of a vision of normal adult person? See, normally an adult person, he can see the objects which are at a distance of 25 centimeter from him, minimum distance, nearby. Okay, so up to 25 distance he can see. See, if he brings this less than 25, what will happen is, the object will be blurred, or it will be visible as two objects. Okay, from 25 onwards means, from 25 onwards he can see the image clearly. So this is the normal range. So near point is 25, means from 25 centimeter onwards the person can see clearly, normal person. Okay, whereas the far point is, we will take it as infinity, means we see the stars, sun, moon, everything which are very very far, but we can see them, right? So theoretically we can say that the far point is infinity, but near point is 25, means from 25 centimeter to range infinity. So a person can see from, if this is the eye lens, okay, you can see from 25 centimeter to how much? Infinity. Okay, this is the range, 25 centimeters to infinity. You can see between this range. Okay, let us move to the next question. Define the power of a lens and write its SI units. So, power is defined as the reciprocal of focal length. So, power is equals to 1 by focal length. Focal length is measured in terms of meter. So, 1 by meter. So, we can write it as per meter, right? So, per meter is nothing but diopter. So, diopter in short we can write as capital D. Okay. So, the power has units of D, diopter. It has the units of diopter. So, let us see some problem, how the problems can be asked. So, here I have taken generally how the questions could be asked. See here, a person with myopic eye cannot see objects beyond a distance of x meter. So, the questions can be, see the person who is suffering with myopia, he cannot see the objects beyond certain point, isn't it or not? Because he cannot see far objects, very far objects he cannot see. But as the object approaches him, at one particular point, he starts seeing them. So, at what point he starts seeing them is the far point. It is called the far point. So, see the far point of a myopic person is x centimeter. So, both are the same. Beyond a distance or far point, if he is asking, both are same. In these type of questions, what we will do is this: a person with myopic eye cannot see objects beyond a distance of x meter, or the far point of a myopic person is x centimeter or x meter. See, so usually what we will do, we will take the object to be at infinity. But since he cannot see after some distance, right, that is the far point, this is the far point. So, this we will take as image distance. Why? Because this lens, what is this concave lens is doing is, see, actually at infinity, if the object is there, the image is not formed on the retina, but instead between the lens and the retina the image is formed. So, for correcting this, I am using a concave lens. So, what this concave lens does is, see that object which is at infinity, it brings the object to the far point. It brings the object from infinity to the far point from where I can see the object. So, see here, that is the reason why we are taking this as the image distance. We are taking this as the image distance. Okay. Now, he will be asked you the power and nature of the lens, right? So, here see what is the mirror formula. The mirror formula is 1 by V minus 1 by U is equals to 1 by F. 1 by V means image distance, this is object distance, this is focal length. Okay. 1 by V minus, what is the object distance? Normally it is at infinity. For myopic eye, we take the object to be at infinity. So, it is infinity. U will be infinity, that is equals to 1 by F. So, 1 by infinity will become how much? 0. 1 by infinity is 0. So, 1 by V is equals to 1 by V. So, if you reciprocate, V is equals to F. And see, V is also equal to what? X. So, V equal to F, V equal to X, which means therefore, V is equals to F is equals to X. And from this, how we can find the power? Power is equals to reciprocal of focal length. So, power is equals to focal length is how much now? X. So, whatever is given, if he is asking you power, directly we can put P is equals to 1 by X. This is how we can do any kind of problem. So, similar kind of problems with values, numericals we will see. See here, A person with myopic eye cannot see objects beyond a distance of 1.5 meter. See, he cannot see the objects beyond 1.5 meter. So, we have to take this distance, okay, as image distance, and object distance, what we will do? We will take that as infinity. Now, what is the other part of the question? The far point of a myopic person is how much? 150 centimeters. Let us convert this into meter. See what will happen? This becomes 1.5 meters, right? Same. 150 centimeter or 1.5 meter is same. Now he is asked the nature and power of the lens, right? Power. So mirror formula 1 by V minus 1 by U equal to 1 by F. The previous case we have seen, right? V equal to F equal to X. Now power is equals to how much? 1 by F is equals to X. So X is nothing but here this one, right? So let us substitute 1 by F is equals to V, how much? Minus 1.5 into 10 by 10. So as to remove this decimal, we will multiply and divide with what? 10. So what will happen? Since after the decimal one digit is there, so I am taking 10 into 10. 10 ones are 10, 1.5 into 10, 15. There is a negative sign, put it there. 5 twos are 5 threes are. So that will be minus 0.67 D. This is the power. Power is equals to minus 0.67 diopter. Okay. See, let us see one more question. See here, a person with myopic eye cannot see objects beyond 1.2 meter directly. So what is the image distance? 1.2 meter. He cannot see beyond 1.2 meter. Usually we will take object distance in myopic eye how much? At infinity. Okay. What should be the type of corrective lens used and what would be its power? Okay. Power is equals to how much? 1 by F, right? We have to find power. So as to find the power, what we will do? 1 by F, right? So 1 by F, from here the formula is there. 1 by V minus 1 by U is equals to 1 by F. So previously we have done, right? V is equals to F is equals to X. So just put here P is equals to 1 by F is equals to what? V. V is equals to 1.2. What is this? Minus 1.2. Minus 1.2 into 10 by 10. That will be equal to 10 ones are 10 by 1.2 into 10, 12. So minus. So what we can do? 2 6 are 2 5 are. If you divide this, minus 0. How much? 6 8s are 48. 2 will be left. 6 3s are. Okay. Minus 0.83 diopter. This is the power. See what would be its power and what type of corrective lens is used. Since what is the power here? We have got the power to be negative. Whenever we have a power negative, which means we will have concave lens. We have to use corrective lens is concave. Understand? This is the corrective lens. See here, normally the object is at infinity and this lens will help us to bring the object from infinity to the far point, so that the image will be formed clearly on the retina. Okay, I hope you understood. Next, let us move to the next question. See here, the far point of a myopic person is how much? 80 centimeter. So minus 80 centimeters in front of the eye. What is the power and nature of the lens required to correct the problem? So just now I have told you, we have been seeing the same kind of problem, right? So V is equals to F. So V is equal to F equal to X is how much here? Minus 80. So power P will be equal to 1 by F how much? Same as V. How much? Minus 80. But here, this is what the students they will do mistake. See, power is equal to 1 by f when f is in meters. When f is in meters. Okay. If f is in meters, but here f is in centimeters now. So we have to put here 100. 0 to 4s are 2 5s are, right? Minus 1.25. If you divide this 5 by 4, you will get minus 1.25 diopter. This is the power. Again, see, the power is negative. Whenever we have negative power, we have to use a corrective lens of concave. We have to use corrective lens, concave lens. Okay, this is how we can do the problem. Let us see the next problem. A person needs a lens of power minus 5.5 diopters. What is the power he needs? Minus 5.5 diopters. For correcting his distant vision, distant means he cannot see the object, distant objects, right? So for correcting that, he needs a power of minus 5.5 diopters. What is the focal length of the lens required for correcting distant vision? What is the focal length? So simple problem, P is equals to 1 by F. Therefore, F is equals to what? 1 by P. You send F to the other side, P to this side. So F is equals to 1 by P. So 1 by P how much? Minus 5.5 into 10 by 10. If you do this, what will happen? 10 ones are 10 by 5.5 into 10, 55. So negative here. 5 2s are 5 11s are. So minus 2 by 11. That is equals to what we will do? Minus 0.18 meters. You will get minus 0.18. Focal length is how much? Minus 0.18 meters. Or if you want to convert this into centimeters, multiply this with 100. You will get minus 18 centimeters. It is approximate. Okay. So this is how we can do the problems. I hope you understood. Okay. These are all the textbook questions and previous year questions, sample questions, everything. Okay. Regarding this myopic eye defect and their problems. Okay. Thank you for watching my video. Thank you.